All right, continuing on. So we'll go with finishing up the key here. So pages 3, 4, and 5. All right, so we got rational exponents and we are multiplying with the same base. Now, on some of the assignments and quizzes, I was seeing that people were actually multiplying these fours together. Okay, you do not want to do that. All right, the rule is we're adding the exponents. By you adding the exponents, that's bringing the fours together. Okay, so when you take an x to the fourth times an x to the fifth, you're bringing those together by adding the two. So that's what we're going to do here. So you're bringing the fours together by taking 3 sevenths plus 18 sevenths. And what that gives us is 21 sevenths. 21 sevenths, 3. So what's 4 to the third? 64. So there's our answer, 64. Okay, next one. This has to do with before we went on this remote learning. So in this problem, remember that this symbol represents the inverse. And basically what that means is the y. Okay, so the inverse is representing a y value. So all it's asking is what is the inverse of the x when x is negative 1? So it's just asking you when x is negative 1, what's the y? That's as simple as that. So when the x is negative 1, the y is right down here at negative 7. So that is our solution, negative 7. Okay, now here's the actual inverse. So which equation represents the inverse of this value? So what's the inverse when the original function is 3x plus 1? I don't know if you remember, but the rules are, this is the same thing as a y. So you have y equals 3x plus 1. Okay, same function. The rules are, first, switch the x and the y. Okay, it's as simple as that. The x and the y switch. Now you solve for the y. So we get the y by itself, so we subtract 1. So we get x minus 1 equals 3y, and we divide by 3. Okay, so I end up with y equals x minus 1 over 3. Sometimes your answer will be written like that. Sometimes they take it a step further like they did over here. And what that means is that the x gets divided by the 3 and the 1 gets divided by the 3. So when we do that, this is the same thing as a 1x. So I end up with 1, oops, there we go. End up with a 1/3 x minus 1/3. That is the inverse. 1/3 x minus 1/3. And our answer is C. All right, which one's equivalent? So it is the third root. Third root. So we need to break that down. So the 128, 2 goes into that. Let me see, I'm dividing it by 2 several times. So 2 goes into that 7 times. Okay. So the prime factorization of 128 is 2 to the 7th. The prime factorization of 54 is 3 to the 3rd times 2. Now remember, we need exponents that are divisible by 3. So I am going to split this up into a 2 to the 6th and a 2, because that's still 7 2's, but 6 is divisible by 3. This guy is okay, because I have an exponent that is divisible by a 3. So 2 to the 6th, if I divide 6 by 3, I end up with 2 squared. Square root 2, because this 2 stayed in. Okay, square root of 3, or cube root of 3 cubed is just 3. This 2 will stay in. So I'm going to end up with plus 3 cube root of 2. So I have 4 cube root of 2 plus 3 cube root of 2 gives me 7 cube roots of 2. So I'm going to add the 4 and the 3. Okay, next page. Okay, here's another inverse function. So what is the value of the inverse of 2? All right, well, in a normal table, you have an x table, and these are the y's. Okay, now remember, g of x is essentially y. So what this is asking is when the y is 2, here's the y at 2, the x is 4. It's as simple as that. So your answer is 4. Okay, solving the inequality. This is what we just finished up with. First step is to solve for the radicand. Okay, So I need, whoops, I need the radicand to be greater than or equal to 0. So negative 4x is greater than or equal to 4. I don't know if you remember this rule from Algebra 1, but when you divide or multiply by a negative, the direction of the inequality switches. Okay, but if we forget that, no worries. Really what we're doing is focusing on this negative 1. Okay, then I need to solve it as normal. So I solve it as just if it were an equal sign. I'm going to subtract 2, square both sides, add 4, divide by negative 4, you get negative 5. Okay, so obviously we have the answers there. Let's just not willy-nilly pick one. Oh, I don't know, I'll pick this one. Okay, let's figure out which ones are actually correct. Okay, so we have negative 1. Ooh, just a second here. Negative 5 is smaller than negative 1 on the number line. So this is how that has to look. So we want to check a number that is less than negative 5. So when I check that number that is less than negative 5 in the original function, so let's go with, say, negative 6. So I have 2 plus the square root of negative 4 times negative 6 is 24, minus 4 is less than 6. 2 plus the square root of 20 is about 4.5, less than 6. That gives me 6.5 is less than 6. That is false. Okay, now we do know and that based off of this function that the x has to be less than or equal to negative 1. Okay, well, if you didn't know you were to switch that inequality, you should do a check. So we'll check, say, a negative 2. So let me get rid of my previous checks up here. Okay, and I'm going to check the negative 2. So I have 2 plus negative square root of negative 4 times negative 2 minus 4 is less than 6. 2 plus, that gives me 8 minus 4, and the square root of 4 is 2. 2 plus 2 is 4. 4 is less than 6. That is true. So far this solution works. Okay, well now how about the last solution? I want a number that is greater than negative 1. So again, let's go with my 0. Okay, because I like 0. All right, so let's give some different colors here. Oh, let's try this little. Pink. Pink. All right. All right. So we have 2 plus, let's go with the thinner one, plus negative 4 times 0 minus 4 is less than 6. 2 plus a negative 4. Square root of negative 4 is impossible for a real solution, so this is out. So my solution has to be between negative 5 and negative 1. All right, so once again, we have another inverse question. What's the inverse given by this solution? So the inverse, again, I'm going to switch the x and the y and solve. So I will square both sides. I'm not quite sure what this thing is. I just now noticed that. Weird. Okay, so hopefully you ignored that because I have no idea what that is. All right, so we end up with y minus 2. I'm going to add 2 to both sides. And that's my solution, x squared plus 2, where the x has to be greater than or equal to 0. I'm not going to get into that whole thing there, but oops. Oh, no, wrong one, wrong one. Beep, 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 beep. That's a negative. I just now noticed that one. It is D. Letter D is our solution. Letter D. X squared plus 2. All right, what is the solution to the equation square root of 2x plus 3 minus 5? Oh, all you need to do is get that x by itself. So we're going to isolate the radical. Ah, it's too big, it's too thick. No, there we go. All right, then I'm going to square both sides. So 2x plus 3 equals 25. 2x equals, subtract 3, you get 22, x equals 11. Now, remember that you should check to make sure that it's not going to be extraneous. This obviously didn't give us a problem where we could get no solution, but you need to check for extraneous solutions. So you'd plug that in, oops, times 11. And add 3, subtract 5. So we end up with 22. Square root of 22 plus 3 is 25. So square root of 25 is 5. 5 minus 5 does give us 0. So obviously that is a solution. Whoops. Do that. All right, so circle. There we go. So we get 11. Okay. Actually, I'm going to pause right here for a moment.